Now we have started moment of inertia. What is moment of inertia? As I have said in your last class, that here the kinetic energy of any rigid body is not only half mv square, as the velocity of different point inside the rigid body is different. So I cannot write that kinetic energy is only half mv square. But I can definitely say that if some particle is placed at a certain distance r, suppose in this example I have taken, that if this is a rigid body and if I say that some particle is placed at a distance r from the point axis of rotation, it is the axis of rotation, right? Suppose it is placed at a distance r, the mass is dm, then kinetic energy of this small particle is, if it is rotating with omega at this instant, it is half into dm into r omega whole square, because the speed is r omega. And if I integrate it, I can find the kinetic energy is half into integral of dm r square into omega square. So this part is known as the moment of inertia, right? Half I omega square. I is the moment of inertia. So what does that moment of inertia do? From moment of inertia, we can understand that if we want to rotate a body about an axis, then how much energy do we need? And by just shifting the axis, you are changing the moment of inertia, and the energy will be different, right? I have given you one example of the pen, that if you are holding that pen at its end, then you can see that the rotation is not easy. Why the rotation is not easy? Because you can see that the particles dm masses are away from the axis of rotation. More the particles will be distributed from the axis of rotation, more will be this integration value, because dm into r square, more will be the value of r, the integration will be more. But if I rotate the pen about the same pen, the same omega, but about the central axis, you will find that it is much easier to rotate. Why? Because now you can see that the particles are closer to that axis of rotation compared to the previous one. And the same pen, if you want to rotate about this axis of rotation, you will find it is again much more easier than the previous one also, because the masses are very close to the axis of rotation now. So if the masses are close, then dm r square integration will be small and the energy will be less. Otherwise, masses will be distributed, energy you will find more, right? Not only energy, this moment of inertia is determines several quantities like torque also, right? Or the angular acceleration also. So if I say that I is the angular acceleration is same, then also the torque, we have not discussed torque yet, but we'll see that that also depends on the moment of inertia, right? For the time being, you can think about the kinetic energy only. If omega same, I is more, so kinetic energy is more. That is the logic I have used in last class to understand what is moment of inertia and its physical significance, right? And this is the formula. I can use this formula to determine the moment of inertia, to calculate the moment of inertia, right? Yes.
So that means less is the radius, less will be the moment of inertia. So therefore less is the kinetic energy.
Yes, definitely. Radius means, look, what radius I will say, that radius are not same for every particle, right? For any particle, if you find the radius is r, for any other axis also that radius will change. So that radius is not same for every particle. I am doing an integration, but from the diagram you will understand that if the particles are closer to the axis of rotation, on an average I am talking about, the particles are closer to the axis of rotation, then lesser will be the moment of inertia, right? If I give you a body which is in the shape of like this, right? A dumbbell like this, this, where the most of the masses are confined here, right? You will find that rotating this body about this axis of rotation is very tough, but rotating the same body about this axis of rotation is very easy. Yes, can you tell me why?
So most of the particles
Yes.
Most of the particles are distributed very close to the second one.
And here the masses are, most of the masses are away from this axis. So that is why this moment of inertia is definitely higher or greater than the moment of inertia, this one. Okay. Till now we have not studied mathematically what is the moment of inertia, but now we will study what is mathematically I can find about the moment of inertia. I think it is clear. This idea is only needed. Again, as the time goes on, we will go into deep in this chapter. You will find what is the other uses. What are the other uses of moment of inertia? Let us first find the moment of inertia of that ring. It is a ring of mass m radius r. If it is rotating about this axis that passes through the center of the ring, then what is the moment of inertia of this ring?
mr square.
Simply mr square, because you can see that I can take a small element dm on the circumference of the ring, and the radius of that small element from that axis of rotation is r. So I can say integral dm r square will be the moment of inertia about this axis of the ring. Then I can say that r is a constant, so I can take r outside and I can do only integration of dm. That will definitely give me the total mass. So the moment of inertia of the ring about this IC is equal to mr square. Now you can see that it does not depend on how the masses are distributed over the ring. Even if the masses are distributed non-uniformly over the ring, can I use the same concept of moment of inertia formula will change or remain the same? It will remain the same, right? Similarly, if I just cut the ring into two halves, two equal halves, each of having mass m by 2, and one half I have placed, what is that? Here about this axis of rotation, another half I have placed here just below that. Both of them are having the same mass m by 2 and the radius is m by r. Then if I try to rotate these rings about this axis of rotation, then what will be the moment of inertia of that system?
The same mr square.
Mr square. Why? Because this ring will have a moment of inertia m by 2 r square, this ring will have a moment of inertia m by 2 r square.
So
right?
The moment of inertia can be added on.
Yes. When we can add moment of inertia? We can add moment of inertia when I have got the moment of inertia about the same axis. Right? Moment of inertia can be added like a scalar. Like scalars. About same axis of rotation. About same axis of rotation. Although I have written this statement that it can be added like a scalars, but remember moment of inertia is not a scalar. I is a tensor quantity, right? Do you remember what I have told you about tensor in vectors? I have just mentioned that term.
Sir, it is just like the vectors, but does not follow vector addition.
It's not like that. Vector more simplifically you can say that. Simply you can say that it is a vector which has multiple directions. Right? Vector should have a unique direction, but this moment of inertia does not have a unique direction. Right? It may be in any direction. We are not going into detail of these tensor quantities, but
It's a current.
yes, but I can say that scalars, why add like scalars? When the moment of inertia is about the principal axis of rotation, all these axes are actually principal axis of rotation, which passes through a symmetric axis or parallel to that symmetric axis, we can take them as a principal axis of rotation. So if they are about principal axis of rotation, we can definitely take it as a scalar quantity, right? So what is principal, what is non-principal axis, we will not discuss them in details. But remember that all the axis of symmetry, they are principal axis of rotation, right? Not all the axes are principal axis of rotation. And if the moment of inertia I can find about principal axis of rotation, I can add them like scalars, right? In your syllabus, there is only principal axis of rotation. So you do not have to bother about whether it's a scalar or tensor, you just add them, right? Because if they want an answer from you, then definitely the question paper setter, he or she has definitely given a axis which is principal axis or parallel to principal axis, so that you can add them like a scalars. Okay, so as here you can see that two rings, the two halves are rotated about the same axis, we can definitely add them up like scalars.
If the upper ring had been of a different radius, then also they might be added up.
Yes, definitely. But
Okay,
the
sir.
answer is not mr square, r1 square plus r2 square m by 2, that will be the answer.
Okay, sir.
So if the masses are on the same side, then also it will be the same.
Same, no problem. Even if the masses are on the same side, does it matter? No. Moment of inertia is m into r square only. Can you find the moment of inertia of this disk? Let us take a small ring which lies at a distance at a radius small r, right? And the thickness being dr. So can I say that the mass of that small ring is the area, which is 2 pi r times dr, area multiplied by mass per unit area of the disk, which is m divided by pi r square. Can I write the mass of this small ring like this? Yes or no?
Yes, sir. Yes, sir.
So what is moment of inertia of that small ring? It will be dm into r square. Moment of inertia of a ring is mr square. Instead of m, I have put dm. Now if I integrate it, yes, dm into r square. Now I will integrate it from 0 to r. So dm is 2 pi and pi will get cancelled out. So 2m by r square and r dr into r square. So it is r cube dr. From 0 to r, the integration is r power 4 by 4. So 2m into r power 4 by 4r square, right? That is nothing but mr square by 2. So the moment of inertia of a disk is mr square by 2 about this axis of rotation.
So can you please explain the dm?
Yes?
How did you get the dm?
dm, we have already mentioned it in earlier chapters, that if you take this ring out and if you unfold the ring, what you will get? You will get a rectangular strip like this.
Circumference, yeah, length 2 pi r.
The length is circumference of the ring, which is 2 pi r. And what is the thickness I have assumed?
dr.
dr. So if you multiply it, the area is 2 pi r into dr. I have multiplied it with mass per unit area.
Okay, sir.
Everyone understood this method? You have to remember this formula, right? You have to make this formula handy so that you can solve the questions. They are very common. Moment of
So
inertia.
wait, please show the solution.
Yes.
Sir,
Bolo.
sir, moment of inertia does not depend on the mass of the means entire body, right?
Moment of inertia depends mr square. So does it not depend on the mass? It depends on
No,
mass
sir,
definitely.
means not proportional. In case of the ring, the mass was less, but the moment of inertia was mr square. And here it is an entire disk, but it is means lower value.
Yes, can you tell me why? If you have a same mass of disk and a ring, why the disk?
Symmetrically, some
Sir,
parts are getting cancelled.
Sir, there the radius in case of a disk, sir, some masses lie. Sir, here the radius is less. Axis of actual radius.
Look, the reason is very simple. In ring, all the masses are placed at a distance r from the axis.
Yes,
And
sir, but here it is
yes.
between 0 and r.
Yes. So the average radius of the disk is less than r or not?
Yes, sir.
Yes. So as I have told you that if the masses are more distributed away from the axis, more moment of inertia. Closer to the axis, less moment of inertia. That is why you have got a lesser moment of inertia for the disk. All right. Now we want to find moment of inertia of a hollow cylinder and a solid cylinder. But we will not integrate, rather we will use a concept called stretch rule. What that rule is, it says that suppose there is a ring and I am rotating that ring about the axis of rotation, this one. About this axis of rotation, I am rotating this ring. Now if you place another ring just below that, if you place another ring of the same radius and the same mass, can I say that the total moment of inertia can be just added up?
Yes, sir.
Yes or no? And similarly, if you keep on placing such type of rings, suppose n such rings are there, then what is the total moment of inertia of the system? Total moment of inertia
nmr square
is nm to mr square. Yes or no? Instead of this n to be finite, if I say that there are infinite number of rings, such rings they are connected like this, right? If n tends to infinity, what you will get actually?
Sir, finite value. Sir, cylinder.
Yes,
Cylinder we will
get
get.
a hollow cylinder, right? We will get a
Hollow
hollow cylinder. So can I say that the moment of inertia of the hollow cylinder? Look, here also I can say that n into m is the total mass of the system. Yes or no? N into m is the total mass of the system. So for a hollow cylinder also can I say that the moment of inertia is simply mr square? Do you understand the logic behind this?
So the last step, what you told.
I have said that if there are n such rings, I can add their moment of inertia and that will be n into mr square. Right? N into m is the mass of the entire system. So this is m. I have assumed the mass of the entire system is m into r square is the moment of inertia. And now I have said that if the number of n is very large, so that you can get a continuous system like this, what you will get basically a hollow cylinder or not? So in case of a hollow cylinder also, if the mass of the cylinder is m, can I write that the moment of inertia is nothing but m r square? Yes or no?
Yes.
Right? Or in other way, we can say that if we have a ring if we have a ring and if we stretch that ring about or parallel to the axis of rotation, it is the axis of rotation, and I have stretched that ring parallel to the axis of rotation, what I will get?
Hollow cylinder.
A hollow cylinder. Can I say that the moment of inertia of a hollow cylinder and ring, they will have the same expression,
Yes, sir.
right? So what does that stretch rule say? It says that if I stretch a body about or along the axis of rotation, keeping the other dimensions unchanged. Here I am not changing the radius of every circle. Radius of each and every circle remains the same, right? Only I am stretching it along the axis of rotation. The expression for moment of inertia will never change. Similarly, if we have a solid cylinder, can you apply stretch rule and tell me what is the answer for this moment of inertia? A solid cylinder, what can I say a moment of inertia is?
Capital M R square by 2.
Yes, that will be mr square by 2. Why it is mr square by 2? Can anyone tell me?
Elemental set D's.
Yes, because it is a disk and I have stretched that disk along this axis and I got the solid cylinder. Yes or
The
no?
stretching means stretching longitudinally.
Along the axis of rotation. Along the axis of rotation. If this is the disk and keeping the radius constant, I can stretch that disk along this line. Stretching means nothing but addition of similar types of configuration about the same axis. So basically I am adding the similar disks about the same axis, yes or no? So if I keep on adding disks about the same axis of rotation, will the expression for moment of inertia change or it will remain the same? It is a stretching a ring, right? Along this line I am stretching a ring and along this line I am stretching a disk. Tell me if there is any doubt in this concept.
So then what will we do in case of a hollow cone or a solid cone?
Can you find a solid cone by stretching something? Yes or no? Is there any element that if we
No,
stretch?
sir.
No.
No, sir.
No, so that is not applicable. That rule is not applicable there.
Sir,
Yes.
if the axis of rotation is not passing through the center, then what will be the effect in its moment of inertia?
That we will discuss. That we will discuss in this class only.
Sir, so if there is a tube which has two and the two ends are there, so one end is expanding very slowly and the other one is expanding very large, so then it will form a conical shape.
Means if a tube is there,
Yes, sir. One end is is being stretched very slowly, and one end is being stretched very
fast.
large.
Why the stretch depends on the rate of the stretching. If I stretch a tube means a cylinder only or not?
Yes, sir. But if they are equal, then it will form a cylinder. But if one is very slow with respect to another, so then it will may form a cone or a frustum at most.
I did not get it. If the radius remains same and if you stretch it, How?
The radius will change now if we change the rate of stretching of the ends.
So then we are not stretching along the axis.
Yes, then we are not stretching along the axis. Are we stretching along the axis?
It is not straight rule then. Not obeying.
Along the axis.
Stretching perpendicular to the axis.
Perpendicular to the
How
axis.
is it coming a cone?
Frustum, it will not be a cone.
It is coming a deformed ellipse type of something.
Yes, that
I
will be
think.
a planar object. If you elongate along this line, stretch along this axis, you will find a planar object only. How do you find a 3D object?
So I think by stretching he means superficial expansion at one end.
No, that is very clear. The rule says you have to keep the other dimensions fixed. If you have to keep the other dimension fixed, only stretch along the axis of rotation. Right? So there, it's not valid in stretch rule. Okay, we'll see also different applications of stretch rule later on. I have written it here clearly. If you stretch any configuration along axis of rotation, keeping other dimensions unchanged, the expression for moment of inertia does not change. Now suppose this is part of a disk. Yes?
Show the previous slide.
Previous slide, this one.
Okay, sir.
Now find moment of inertia of the part of a disk as shown in figure about axis of rotation passing through center and perpendicular to the plane. The part has mass m and radius r. This is not a full disk, right? This is part of a disk. Like if you have a pizza and if you have cut one portion of that pizza like this, so it is that one portion of that
MR
pizza.
square.
No, it's not MR square. It's a disk. It's like a disk and you have cut one portion of the disk.
Sir, MR square by 2.
It's still MR square by 2.
So it will obviously depend on the theta.
It will not depend on theta.
Theta is 90 degree.
It will not depend on theta. It's not 90 degree. Even if it is not 90 degree, then also the answer is MR square by 2.
Yes, sir, then also it will be same.
Yes. Look, suppose this is one complete disk, right? And I cut that disk in several small parts like this. As many parts you make, no problem in that. But all of the parts are symmetric, yes or no? All of the parts are symmetrical?
Yes, sir.
So if I say that the mass of this segment is m and the moment of inertia is I, then can I say if there are n such segments, so n into I is equal to the total mass of the disk is n into m into r square by 2. Can I write it? About this axis perpendicular to the plane, if I rotate that disk, what is the moment of inertia of the disk about this plane, about this axis perpendicular to the plane? Is it mr square by 2 only or not? But what is the total mass of the disk? Is it n times m or not? And if each of the segment has a moment of inertia I, then for n such segments, the moment of inertia will be n into I. So what is the moment of inertia I? Can you
So
see?
what-
It is only
So
mr
there is
square
no
by 2.
integration.
Yes.
So there is no integration.
Why I will do integration? Do I know what is the moment of inertia of the disk? Should I again do integration, or I can use that moment of inertia mr square by 2, the formula?
Okay.
Have you got
Sir,
it?
but if the whole mass of the disk was said to be small m, then what would be the mass of the small fraction of the disk? Then it will be dependent on the angle of theta.
That it will depend on how many sections you have done. If there are 10 sections, m by 10 you do. Right? No one is going to ask you about the total mass of the disk. Definitely the mass of the portion will be given and the radius. Now if I say that I will cut that disk not with that straight lines, but rather I will cut that disk by this type of lines. Right? Such that the mass of each segment is m. Now can you tell me what is the moment of inertia of each segment?
Sir, mr square by 2. Same.
Same.
The same moment of inertia you will get as mr square by 2. Why? Look, because the same concept is applicable here also. So what can I conclude from this example? I can say that if we have to find moment of inertia of any segment such that if I add such similar segments about an axis and I get a complete body, then complete body you should get, right? Then can I use the same expression for the complete body as the expression for moment of inertia of each part? Yes or no? Do you understand what I have said? I can say that if we have to find moment of inertia of any portion such that when we add such portions about any axis, we get a complete body. Then moment of expression for moment of inertia of each portion is same as that of the complete body. Is that statement correct? Have you got the idea? Yes or no?
Yes, sir.
If we stretch any configuration along axis of rotation, keeping other dimensions unchanged, the expression for moment of inertia does not change.
Here, other dimensions refers to what?
Other dimension means if it is a disk, the other dimension should be the radius. If it is a rod, it should be the length. Right? You are stretching along one dimension only. Right? You are not stretching simultaneously about in any direction. If it is a xy plane, suppose this is a 3D body xyz, so you can stretch along z axis. But you should remember that along x and y axis, whatever was the arrangement, that should remain constant. That should not change. If it also changes, then actually you are not adding the similar type of structures. Then stretch rule is not valid. Right? So very means small or rare application of that stretch rules are there, but you can apply. Basically, you can understand that the stretch rule is nothing but addition of the similar structures along the same axis. That is the stretch rule. Now I need to find moment of inertia of a rod of mass m length L about the axis of rotation. That first axis of rotation passes through the center and perpendicular to the rod. Right? This is I1. Second one is passing through center and makes angle theta I2. Third one is passing through the end. And
So theta with the vertical or theta with the horizontal?
Theta with the rod. In the same plane. I1, I2, I3, all of them are lying on the same plane. Right? Same plane as the rod. Have you done it?
So is the last one ml squared by 3?
Yes.
So and for the second one, is it ml square by 12 into sine square theta?
Yes. Let us take this rod. And suppose I want moment of inertia about this axis. What I will do, I will go at a distance x from the axis. I will take a very small element of length dx. I will find the moment of inertia for this length about this axis. What is moment of inertia of this mass of this element? M by L into dx. So moment of inertia of that small mass is dm into x square, yes or no? So that is m by L into x square dx. And I will integrate this moment of inertia, and here I will integrate the value of x. What should be the limit of x? Can you tell me?
Minus L by 2 to L by 2.
Yes, this is x equal to 0, this is x equal to L by 2, this is x equal to minus L by 2. So that is from minus L by 2 to plus L by 2. X cube by 3, so it is m by 3L into 2L by 2 cube, L cube by 8. Right? So it is ml square by 12. Have you got the calculation? In second, if it is at angle theta, suppose here, also I will do the same process. At distance x, I will take a small element of length dx, and this angle is theta. So what is the distance from the axis of rotation to that element? Now it is no longer x, it is x sine theta instead. So I can find the moment of inertia is dm into x sine theta whole square, right? So instead of dm x square, I have multiplied with x square only, right? Sine square theta. So di is equal to integral of sine square theta multiplied by dm x square. What is dm x square? From minus L by 2 to plus L by 2. Here also x will vary from minus to plus L by 2. That already we have calculated as ml square by 12. So it is ml square by 12 sine square theta. Have you got it?
So why have you taken x and theta?
Why you have taken x sine theta? Because moment of inertia always is calculated by summation of dm r square. If you remember in slide, I have mentioned that here r is the shortest distance between the axis and the point. What is the shortest distance between the axis and the point? If you draw perpendicular, then only you will find it.
Yes, sir.
Okay. And passing at the end, the axis of rotation passing through the end. It is the axis of rotation. Now I will take the same element x at a distance x of length dx. Right, dm is still the same, m by l into dx. Di is mx square dmx square only. But here the integration limit will change. Right? What is the limit here?
0 to L.
0 to L only. Right? Because this side there is no rod. So 0 to L. 0 to L is L square by L cube by 3. So that will be ml square by 3.
So what is the dm?
dm is the mass of this element. Small element.
dx, sir, dx.
Yes. What is dx?
Yes, sir.
dx is a small length where the mass dm lies in between x and x plus dx. dx is this thickness of this rod, length of this rod. This dimension is negligible. The length of the rod is dx for this mass dm. So if the total mass is m for L, then for dx part the mass will be m by L into dx. We have taken this type of integration in center of mass also. You should remember it. Right, we are not doing integration first time. We have done the integration earlier also. Do you remember all those integrations in center of mass chapter? We have taken elemental ring or elemental disk, right, or elemental length. Then we come to integrate. Look, as I have done in our last class, we have seen that for the pen, which was very similar to that rod, when you are rotating about the axis, it was tougher than when it was rotating about the center. Look, about center it is only ml square by 12. About axis it is 4 times of the moment of inertia, right? So basically you needed more energy for this rotation.
Yes, sir.
So please wait.
Okay.
So in the last part, we can also apply the law of parallel axis.
Parallel axis we have not yet studied. Parallel axis we will study and then we will apply definitely. Is this clear?
Yes, sir.
Can you find moment of inertia of that rectangular plate of mass m and dimension a into b? So you can assume this dimension to be a and this dimension to be b. About the axis of rotation parallel to its sides passing through the end.
So here can we do it by like the stretching of a rod?
Yes, you should do it in this way. So
So
what
then
is
this
Ix and
means the same term.
yes?
mb square by 3. mb square by 3.
Yes. So Ix, if I talk about Ix, what can I say about Ix? What about Ix?
So m is square by 3.
M is squared by 3. Look, if it is Ix, can you imagine a rod lying like this? And if you stretch that rod along the axis, will you get the same rectangle? Yes or no?
Yes, sir.
So whatever is the moment of inertia of this rod about this axis, the expression should remain the same? Yes or no? Stretch a rod. So this moment of inertia will be m a square by 3. Similarly, if you think about Iy, which rod you will stretch? Iy?
Upper one.
Of length B.
Yes, of length b. I will stretch about this axis. You will find the same rectangle, right? So Iy is m b square by 3, right? And similarly, if they are passing through the center, if this is the axis, suppose it is the axis of rotation, then what will be the answer for this one? Suppose x prime and y prime.
So it will be m square by 6 and mb square by 6. 12.
Yes.
12 it should be now.
Yes. X prime will be m square by 12.
Yes, yes.
The rod was by 12, right? M square by 12.
3 into 4.
And y prime is equal to m b square by 12.
See, is there anything called a total moment of inertia? Means the net moment of inertia.
No, moment of inertia is only one thing. Yes, as I have said, it is a tensor, so it can have components. I am not going into that part, right? For your calculations, for in your study, always it will have one moment of inertia. It's a scalar quantity, no components, nothing is there. Can you find moment of inertia of this triangular plate which has mass m, height h, and base length L? Okay. Let us take a small element of thickness dx at a distance x. X I can measure from here, right? The thickness is dx. Can I take this as a rod? At a distance x, I have taken a small elemental rod of length dx, of thickness dx, and I can assume this to be y. The height of the rod is y. Then what is the mass of that rod? Can you tell me what is mass of that rod? What is the area of that rod? Y into dx or not? Into mass per unit area, that is half into L into H. Have I got it correct? Yes or no? Again, I can say that y by x is equal to h by L. So y is equal to h into x by L. So what is di? Can I say di is equal to integral of dm into? What is moment of inertia of this rod about this axis? Is it ml square by 3 or dm by 3 into y square? So 1 by 3 into integral of dm y square, if I do it, dm means 2m by lh into y dx, hx by L into dx into y square, means y cube will be there, dx. The integration should be from where to where? Should I vary the x? Can you tell me from where to where should I vary the value of x?
0 to L. Just 0 to L.
0 to L, okay. So
So the opposite of it.
1/3 2m by lh into h cube by L cube. X cube dx is how much? X power 4 by 4. Yes or no? So look, L power 4 and L power 4 in numerator denominator got cancel out. H square will be there in numerator and 6 will be in denominator. That should be the answer of this question.
Sir, why is it from 0 to L? We are measuring from right side to left side.
So I have assumed x starting from here. Doesn't matter from where you are starting here. This is not a vector quantity. Magnitude does not matter. I've started
Okay.
x from here 0 and x will vary from 0 to
So
L.
then also it will be only a minus sign.
No,
Nothing
no.
else.
Even if you start from here, then also you will find the same answer. Right? You try it, same answer you will get. Find the moment of inertia of the same triangular plate of height h, base length L, but about this axis I x prime now. It parallel to x axis, passing through its vertex. What is I x prime?
So we can use negative mass concept in this.
Yes. Look, if I do it like this, that I have placed another similar triangle here, so that the mass of this triangular portion is m and mass of this triangular
So
portion
then
is
it will be a
also.
complete rectangle.
Then it is a complete rectangle, yes. So then what is the rectangle, this ix prime for that rectangle? I for this
So
rectangle,
2mh square by 3.
2m into
H square by
h square divided by 3.
Yes.
It
And
is
then we
m
can
square
subtract
by 3.
ix.
Yes. And from there, if I find what is the moment of inertia of this triangle, suppose this is t. Moment of inertia of this t about x prime axis. What
The
is
same
that?
as ix.
Is it
Ix.
m h squared by 6? Yes or no?
Yes, sir.
So ix prime of this triangle, that is equal to I of the rectangular portion minus I of the triangular portion. So 2 by 3 minus 1 by 6. So that is 1 by 2. mh square by 2 will be your answer. You can also do the same thing by taking uh, a rod, right, and setting the integration limit not from 0 to L but for a particular rod. Again, it will be difficult to do this integration. First, you need to find the moment of inertia for a rod, arbitrary rod, then you have to integrate it. But this method is also useful because I know the rectangular moment of inertia, rectangular plate. I know the triangular plate. If you subtract them, you are easily finding the moment of inertia of the.
So are these two triangular plates are similar?
Yes, if it is a rectangle, it should be similar.
Yes.
It's
So
a diagonal.
can't we say that the inertia for that triangle T will be the same for the other triangle?
No.
About which axis? Yes, they are similar. The triangular T, the moment of inertia about x prime is the same as that of the moment of inertia of this plate about x axis. Yes or no? About this axis and about this axis, their moment of inertia is same. About this axis, vertical axis. About y axis and about this y axis, they are same. But about this x and x prime axis, they are different. Have you got this concept? If there is any doubt, you can ask me. What I have done, I have first taken another similar triangle to make it a proper rectangle, used the formula for rectangle, then I have subtracted the formula for triangle because I know that about base it is mh square by 6. Then I can find this triangular plate about its vertex. Is
So I
this?
can't understand how did you calculate the moment of inertia of rectangle as 2mh square by 3?
We have already done that. Do you remember in last just one or two questions back? We have used stretch rule of
Yes,
that
sir.
rod.
Yes, sir.
If you stretch that rod, you will find the rectangle. So what is the moment of inertia of this rectangle? Total mass of the rectangle is 2m. M into h square by 3. Because the
Okay, so
moment
the
of inertia
mass
of the
was
rod
okay.
is h squared. Yes. This mass is 2m, na? Total mass now.
Yes, yes.
I think it is clear to all of us. Okay. Can you find the moment of inertia of this rectangular plate about its diagonal? The mass of the plate is m and the dimensions are 3 meter and 4 meter. What about the moment of inertia about this diagonal? Okay.
So 5m by 12.
Yes.
5m by 12.
5 by 12. No.
So 25m by 6.
No. Total mass of the
The
rectangular
12m by 25.
12 by 25. Uh, no, I think. Look, if the total mass of the plate is m, can I say that this mass is m by 2 and this mass is m by 2? Yes or no? Now if I drop a perpendicular from this side, this corner to that length,
Yes, sir, it's coming 25 by 24 only.
okay, let's check.
Previously, I said that only.
Alright, it may be. Just check it. So what is that height h can I find? Half into h into 5. That should be half into 3 into 4, yes or no? So h is 12 by 5. So can you tell me what is the moment of inertia of this upper triangular plate about this axis?
Ma square by 6.
Yes,
Means m by 2 a square by 6.
m by 2 h square by 6. And for the lower part it is the same or not?
Into 2.
So what we will get?
144 by 150.
2 gets cancelled out. So 144 divided by 25 into 6 m. So that should be 24 by 25 m. What you are saying? 24 25 or 25 by 24?
25 by 24.
How?
The opposite. 24 by 24.
Yes. How did you get that 25 by 24? Understand your where you have done wrong, right? This question says find the moment of inertia of the rectangular plate of mass m dimension a into b. This dimension is a, this dimension is b. About an axis of rotation that is inside on the plane, passing through the center. This is the center. And making an angle theta with the horizontal line. So that angle is theta. Right, it's not a simple question. No formula you can use here. But if you try, you can do it, right? So I will leave this question as your homework. Think about it. It will definitely depend on theta, A, B, mass, all of the quantities will be there. Right, but what will be the answer of this question? Think and we will solve it in next class, right? But think about it at least. Next, I want to find the moment of inertia of a hollow cone that has mass m, radius r. About the axis of symmetry, I am rotating it. Can you find it? What type of element here I should take?
So rings.
A ring, yes, small rings.
Is it mr square by 2?
Yes, sir. mr square by 2 is coming.
Yes,
Yes. Yes, it is mr square by 2. How do I find that?
So by taking small rings at height h, small h, and then using similarity to eliminate h.
Okay, so I will take a small ring here. Suppose I have taken that ring not at a height but at a depth, right? Suppose this is y, right? And this height is dy. And the radius of that ring is r. What can I say about the area of that ring?
The 2 pi r into dy.
2 pi r into, is it dy?
No, sir. There will be a sine theta term as well.
Or dy
So
sec
cosec
theta?
theta.
dy sec theta.
dy sec theta, yes sir.
Look, if I unfold the ring, then this width of the ring, that will not be dy, because dy is this one, dy is this height, right? If you take dy is this side, this is dy, but the ring lies on the surface. So what is this length? If this is theta, is it dy sec theta or not? That is why I have taken this as dy sec theta. Have you got, everyone, this one? From similar triangle, I can also write y by r is equal to h by capital R. So y is equal to r by capital R into h. And dy is equal to h by r into dr. So area of that ring, I know area of that ring. Now I can find the mass of the ring dm. Can I write mass is area multiplied by mass per unit area of that cone? What is area of that cone? Pi RL, yes or no? If this slant length is L.
Yes sir.
Area is 2 pi r into dy sec theta. Dy is h by r dr into m divided by pi r L. Right, look, pi gets cancelled out. So that is 2h sec theta into m divided by r square L into r dr. Have I got dm correct? Just check. Then I will find what is moment of inertia for the ring. It is dm into r square only or not? So dm into r square is 2. Achha, what is h sec theta? H sec theta is also L or not?
Yes sir.
So h sec theta and L will get cancelled out. So it is 2m by r square into r cube dr. If I integrate it from r equal to 0 to capital R, I will find the moment of inertia as mr square by 2. Have you got this integration? Yes or no? Is this clear? Now there is one alternating observation of this problem that you have to understand. Suppose this is one axis of rotation and I have a ring here, I have a ring here, and the moment of inertia is I. I have the same axis of rotation, but I have the ring here and I have the ring here. What is the moment of inertia?
Same in both cases.
Will it also be I or not?
So same.
Same, because it is also mr1 square plus mr2 square. This is also mr1 square plus mr2 square.
Eventually,
Does
it will
it-
create a
yes.
disk.
Does it matter where you are placing these rings along the axis? Even if you place this ring below the axis of rotation, will the moment of inertia be the same? Yes or no?
Yes sir.
Similarly,
That
if
means
you
the
have
hollow
a
cone and the discs are same.
yes, if you have a disk, you can imagine that disk made of infinite number of such rings, yes or no? Now what you do, you one by one shift that ring vertically upward. So you have a small ring here, just below a bigger ring, bigger ring. You will get this type of structure. If the moment of inertia of this is I, can I say the moment of inertia for this is also I? Yes or no?
Yes, sir.
So for a hollow, if you move that disk rings upward, what eventually you will get? This configuration is nothing but what? Hollow cone or not? Can you visualize that situation? So what is moment of inertia for a disk goes well for moment of inertia of a hollow cone, because it does not matter where you are placing the rings. If the axis of rotations are same, moment of inertia should be the same. Hello, Eta? Look, we can take a small disk like this.
So 3 by 10 r square.
Yes, 3 by 10 mm square. Good. Small disk like this. That disk lies at this distance y. The thickness of the disk being dy. So what is the mass of that disk? The area is pi r square and the thickness is dy. Here we will not take the slant height because volume is determined by the actual depth, right? Into mass per unit area. Mass per unit volume is 1/3 pi r square h. Have I got it correct? Similar here, if this is the radius r, you can see y by r is equal to h by capital R. So y is equal to r by capital R into h, right? dy is equal to h by capital R into dr. So dm is equal to pi will get cancelled out. So 3m by r square h, 3m by r square h into r square dy. R square into dy is h by r into dr. And what is di? Moment of inertia of that small disk is dm into r square by 2, right? So I'll integrate.
What is the formula answer? 3m r square by 10.
Yes, yes. So that is equal to 3m h. Okay, h will get cancelled out. So 3m by r cube into r square dr, by 2r cube, r square dr into r square, r power 4 dr. Integrate it from 0 to r, you will get 3m r power 2, 3 and 5 by 10. So that should be the answer of this question, 3m r square by 10.